So today in class, we learned about significant figures, and I posted a video about how to identify significant figures. And uh, I promised I would put one together about calculating math problems based on significant figure rules. So the significant figure calculation rules are: when you multiply and divide, answers can't have more significant figures than the factor with the least. So what that means is, now you can pause and write that down if you need to. Answers can't have more sig figs than the factor with the least. If I have a number, say 5, and I multiply by 15, I'm going to get an answer of 75. And that's fine if you're in math class. But if you're in science class, and those are measurements, and that is in square meters, then the 75 is going to have to be adjusted because we can't get an answer that is more specific than the information that we put in. So this only has one significant figure. This number has two significant figures, so our answer can't be more accurate than the stuff that we put in. So we have to round this off so that it only has one significant figure. So the 7 is followed by a 5, you're going to round it to an 8, and then put a 0 in to hold the place. And that 0 will not be significant because there's no decimal. So then we've made an answer that matches our data. So if our data only had one sig fig in one of the numbers, then our answer can only have one. And so what that means is like we talked about in class, if I have a rectangle here that has a length of 8 meters on one side and 4 meters on the other side, well, your math teacher would say that 8 times 4 is 32 square meters. Your science teacher would say, well, we don't know that 4 really means 4 because in a number the last digit is estimated and 4 is the last digit, so therefore it could have been 3.5. Could have been 4.5. We don't know. So all we know for sure is it's somewhere around 4 and this is somewhere around 8, and so with one sig fig here and one sig fig here, we have to round this answer off to be one sig fig. So all you can say for sure is that 8 times 4 is 30. So you can't be more accurate than the information you put in. And so you're limited. In science, you want to be both accurate and precise, but you can't be more precise than what you know. So when you're multiplying, you can't have more sig figs than a factor with the least, or when you're dividing. So if I had 15 times 0.001, well, that would give you 0.015, but that number has one sig fig, that number has two. Remember, zeros in front are not significant ever. They are never significant. So you'd have to round this number off to one significant figure. So you'd call it 0.02. All right, because this 1 is followed by a 5, and that would round the 1 up. And that is one significant figure because zeros in the front are never significant. So there you go, some examples for multiplying and dividing. When you add and subtract, you have to round to the least precise place, and that is of the elements that are the numbers that you put together to get your answer. So take a look at an example of that. If I had 14.43 and 8.487, you add them up. 7, 3 and 8 is 11, 8, 9, and 12, and carry 1. So we would end up with, 12 carry 1 is 2. So 22.917. So then the question becomes, which number is in the least precise place of those numbers that we added? So we're looking at the 3 compared to the 7. Well, the 3 is in the hundredths place, and the 7 is in the thousandths place. So if you're looking at a hundredth of a meter, it's about this long, just picking meters for example. But if you look at a thousandth of a meter, it's about like that. So which one of those is less precise? The 3 is in the hundredths place, which means it's somewhere in a space about this big around 3. And the 7 is in a thousandths place, which means it's in a space about this big around the 7. So which is less precise? Well, if you're throwing darts and you can always hit right here, you're very precise. But if you're throwing darts and you kind of hit everywhere around in here, then you're not as precise. So this is less precise than this, which means a 3 is less precise than a 7. If you're going to round to the least precise place, then you have to round off to the hundredths place because the 3 is in the hundredths place. So our answer would be 22.92. So there's your final answer for this kind of question. So when you're adding and subtracting, you round to the least precise place. All right, so that's a short video that covers the content about how to do calculations with significant figures. So try some of the practice problems that I put online, and I'm going to end the video there.